Rahman Rahim. Let's look at this question. In the class, we did draw the moment diagram. Here, he need the moment, bending moment, and he need the moment as a function of x for each segment. So let's extend the line. Extend the line and draw an axis, and we call this moment. You have to put description, and of course it's kilonewton meter. Be careful with the description. You have to put it as is. If it's Newton meter, if it's kilonewton, if it's pound, feet, we have to put the units, and you have to put description for any axis. Moment is m. Units is kilonewton meter. So initially we will start with a moment 0 at the hinge. Let's have another color. So initially it will start from 0, but this is, here there is a triangle. I'll draw it here. Triangle here. And there is a 0 shear. Shear is 0 here. And there is another triangle here. And there are similarities between triangle, this smaller one and the bigger one. So let's assume this is x, and we need to find this distance, x. The x, in order to get a 0 shear. And so this one is 4 minus x. This is the other distance from the other side. So 9 over x, 15 over 4 minus x. So you could find out this distance. This is very simple. If you do 9 times 4 minus x equal 15x. If you put it in your calculator, you could find x is equal, check it please in your calculator, it's 1.5. We did this in class. We did find this 1.5. So this x is 1.5 meter. Let me erase this. So this is 1.5 meter. What is the area of this triangle? Let's call it area 1. It's 1/2. 9, this is this side, times 1.5. 1/2 times 9, which is 4.5 times 1.5. We did this. That's going to give you 6.75. That's the area here, the area 1. So at this 0 shear, you'll have a strong moment. And since the shear is linear, the moment will be concave down. And this is 6.75. Let's find the other moment. The second area, 1/2 times 15 times 4. I really don't remember that. 4 minus 1.5. That's 2.5 here. That's remaining from the 4 meter. 1/2 15 times 2.5. Remember, this 15 is minus because here we have to account for the negative moment. So 2.5 times 15 divided by 2, and that is minus 18.75. So this is a negative plus 6.75. That will give you minus 12. So you're going to go. Still, you can see that this is linear. So you're going to go concave down concave down, non-linear, to minus 12. Remember here there is a zero moment. This is very dangerous. We have to find this. Moment is 0 at this point. Okay, so minus 12. Again, this is non-linear. And this is non-linear. And then we'll find the last area here. Area of the shear, 1/2 times 12 times 2. This would give you plus 12. So minus 12 and plus 12 is 0, and that is a good check. So the moment at the end here is 0, and that's a good check. Yeah, that's right. So plus 12 minus 12, still it is curve. It's concave down, so it's minus 12, and 12 is 0. So you're going to go back to 0 here. This is a negative moment, and this is a positive moment. And we have to wash it out. Moment here is equal to 0. The location is very important. That's why we have to find the equation. Now, we need to find the moment at every segment. Here we have two segments. We have one segment at this point, just before the ruler. And we have another segment just after the ruler. These are the change of loading to find the moment equation. So let's look at the first segment. Let's do the first cut. Let's say cut A. You can see it. Only there's a load 9 kilonewton, and there is 6 kilonewton per meter, and there is X. You're going to find the cut, the moment at this AA at a distance X from the 9 kilonewton. So let's draw it. Remember, it was loading is down 6 kilonewton per meter, and this distance is X, and there is another load up, reaction here is 9 kilonewton. And do we need to find the shear? No. Let's assume that there is a moment this way. Let's find the moment at this point. So measure a moment at this point, moment, which is positive. And the 6 kilonewton, this is Newton or kilonewton. And now I have, this is kilonewton. 6 times X, that will give you a point load, 6X. And this distance is X over 2. Okay, so moment, which is a positive moment, and plus the 6X will do a positive moment times X over 2. And this force will do a negative, minus 9, distance is X, equal to 0. So moment plus 6 over 2 is 3x squared minus 9x equal to 0. So the moment of the first segment, it's 9x minus 3x squared. So the moment is a lot of, it is a moment from here to here, it is 9x minus 3x squared, which means that we could find the zero moment. So let's do this equation, moment equal to 0. Let's find moment equal to 0 for the first segment. So we'll do moment equal to 0, 9x minus 3x squared equal to 0. If you take 9 minus 3x, take the other x outside, 9 minus 3x, 9 equal 3x, x equal to 3 meter. This is good, which means that the distance from here to here is 3 meters. And the distance, this is 4, right? Yes. The distance from here to here is 1 meter. Good. We found the segment. Now let's find the moment equation from here, from the ruler to the end of the beam. So this is, let's just call this one moment 1, moment segment 1, and let's find moment segment 2. Moment segment 2, remember, we're going to do the cut BB. This cut, I'm going to include the distributed load from 9 to 27, and then there's an extra load, and I'm going to call it X here. Let me draw it for you. Ooh, I don't have space. I'll do it here. I'll try to do it as much as I can before. This is 9 kilonewton, and we have here 27. Is it 9? 27. 6 kilonewton 4. This 6 kilon, and this is 4. And I have an extra X. And you can see that this extra X, it has also another load, which is 6 kilonewton also per meter. And I need to find out this moment. Okay, let's look at the first point load. 6 times 4 6 times 4 is 24 kilonewton. This is the load for the 4 meter. And the second load for the X, it is 6 times X. 6 times X. 6 kilonewton times X. And of course, it is X over 2 from here. And it is from here to here. It's 2. I mean, no, sorry. So from here to the point of the moment, it is 2 plus X. So let's do moment at this point. It is moment minus 9. This 9 will produce a negative moment. 4 plus X minus 27 times X, moment at this point, plus 24 times 2 plus X, plus 6X, times X over 2, 24, 2 plus X minus 27X minus 9. Okay, good. So now we could find the equation. Moment. And let's call this one moment 2. Moment 2, moment of the second segment. Let's open up everything. 36 plus 9. I took the minus 9 the other side, so it's plus 9x. Of course, the 27, I took it to the other side. And this is minus 48 minus 24x minus 3x squared. Okay, so if you find the second moment, minus 12 plus 12x minus 3x squared. And that is the second moment segment. Minus 12 plus 12x minus 3x squared. Okay, good. So that is the moment at this segment from the ruler to the end. Okay, we are done from this. We're going to go for the next 4a.